Let's take a look at quadratic functions. We'll look at how to identify quadratic functions from tables and graphs, and we'll learn how to write the explicit form of a quadratic function. So down here we have some data. I have graphed this data here and played connect the dots, and we can see that it has this shape to it which tells us that it is a quadratic function. This shape on the graph is called a parabola. So when you graph a quadratic function, you will get a parabola. To identify quadratic functions from a table in which the x values each increase by 1, which they are doing here, we're going to check the values of the outputs, just the output values, just the outputs, for a common second difference. When I find a common second difference, and we'll do that here in just a moment. After we finish off these notes, I spelled difference wrong. D-I-F-F-E-R-E-N-C-E. Explicit quadratic function rules can be written as y equals, we have ax squared plus bx plus c. X and y, as always, represent any point on the graph. In this case, the graph of a parabola, where x is input and y is output. Ordered pairs are always written as x comma y. A is going to represent the leading coefficient. The leading coefficient. So we call A the leading coefficient. We can calculate this by taking our common second difference and multiplying it by 1/2. The C of the explicit function rule is the y-intercept. So the parabola's y-intercept is represented by C. As an ordered pair, we'd write this as 0 comma C because of the definition of what a y-intercept is. It's the value of y when x equals 0. The only variable we have left is b. That's the linear terms coefficient. It's the coefficient of x to the first. One way to calculate this value is to first calculate the values of a and c. Then we're going to substitute in an ordered pair off our parabola for x and y. Then that b will be the only variable in the equation. We can then use properties of equality to solve for its value. So that's one way of doing it. It's probably the simplest way. But there are other ways. And if you'd like to practice those, let me know. All right, so now we've gone through the vocabulary. Let's take this for a spin. So the x values are increasing by 1. So we're going to check the differences in the outputs. We're going to notice that it's not linear. So we say from 2 to -6. What's the difference? Well, -6 minus 2 more is -4. I think I said minus 2 more. I should have said -6 minus -2. From -6 to -8. -8 minus -6 is -2. So we know it's not linear for sure. And from -8 to -8, it's just plus 0. So it is not linear. We could also check for exponential at this time if we wanted to. We could find out very quickly that it's not exponential. If it's exponential, there should be a common ratio. And I can see from here to here, the common ratio would be -6 over -2, which equals 3. And from here to here, it'd be -8 over -6. And we know that -3 is not equal to 4/3. We know it's not exponential. We know it's not linear. We're going to check for quadratic by looking at the common second difference. So now we look at the difference from here to here and from here to here. And -2 minus -4 is plus 2. 0 minus -2 is plus 2. Our second difference is common. And that lets us know that it is quadratic. We can now calculate the values of a and b and c so we can write our explicit rule. A is always 1/2 that common second difference. The common second difference is 2. So in this case, A will equal 1. B we'll have to use substitution to calculate. C we can calculate off the bat because the table was nice enough to give us the value of C. It said, hey, when x is 0, W of 0 is -2. That is the y-intercept. So now we have to calculate B. So we'll just need our output value. We can pick any point on here for it except for the y-intercept. If we use the y-intercept here, we won't be able to calculate B. So let's just pick probably the easiest point of all, and that is the value of y when x equals 1. Because if x equals 1, we're going to do b times 1, and b times 1 is just b, and b is what we're solving for. So by giving b a coefficient of 1, we're going to make our job a little bit easier here. So we need to have y equals, we know a is 1, so we have 1x squared plus bx plus -2. I'll write that as -2. Now we'll just substitute in a value for x and y. So I put -6 in for y. I'll put 1 in for x. So 1 squared, b times 1 is b minus 2. Now we can just use our properties of equality. We can simplify things. So we get -6 is equal to 1 plus b minus 2. I can simplify the right side of the equation a bit more. 1 minus 2 is -1, so we get -1 plus b. I can then add 1 to this side to cancel out that. Add 1 to this side to maintain balance. I get -5 is equal to b. So b equals -5. Now I can write my final function rule. My output is w of x. So I'll say output is equal to 1x squared minus 5x, or I could write plus -5x, minus 2, or I could write plus -2. To check to make sure you are correct, you'll want to use substitution. For quadratics, you'll want to check 3 points. So I'm going to check, I'll check this point, and I'll check this point, and I will check that point. So in the first point here, when the output is -2, my input is 0. So I get 0 squared minus 5 times 0 minus 2. I get -2 equals, well, that's going to be 0, and this is going to be 0, and 0 minus 0 is 0, and 0 minus 2 is -2. So far it's looking good. Now I'll check this point, and so when the output is -6, my input is 1. Input is 1. I get -6 is equal to 1 minus 5 minus 2. -6 is equal to, there's a -4. -4 minus 2 more is -6. So it's looking good so far. One more point just to make sure we're correct. And that'll be this one right here. And so I'll put in -8 for my output. I'll put in my 2 for my input. And I get -8 is equal to 4. I actually want to use distributive property here. I want to, I'll do that at the end. But when I see things like this, I like excuses to use distributive property. I'll just simplify it and not be fancy though for now. So I do -10 minus 2 more. I get -8 is equal to 4 minus 10 is -6. -6 minus 2 more is -8. So if I'm going to stay to the very end, I'll show you how my brain sees expressions like that when I'm simplifying them. Otherwise, just continue to practice looking for quadratic patterns by looking at the common second difference, calculating a, the leading coefficient, by taking half of that common difference, getting c's value from the table. It's always the output when the input is 0. It's the y-intercept. And then calculating b by substituting in an ordered pair into the equation you have so far, where b is the only variable left. And again, I strongly suggest using 1 comma something as the point you check. That way you get a coefficient of 1 for b. So continue to practice. As you make errors, analyze them and ask any questions you have. And if you're still sticking around to see how my brain works, here we go. So when I see expressions like this, I would get negative 8 is equal to 4. And then what I see here is I see plus negative 5 of these 2's, and I see negative 1 of these 2's. So now I can use my associative property of addition to group these two terms together. And now I can use my distributive property to factor out the common factor they have of 2. So I'd get 4 plus, and I'd factor out the 2, and I get negative 5 and negative 1. I guess I should use brackets there to look a bit more fancy. Parentheses inside parentheses, a little bit on the sloppy side. So then I get, I shouldn't be working up. Probably going to run out of room. Yep, almost out of room. That's okay. I get 4 plus 2 of these negative 6's. And that would be 4 plus negative 12, which does equal negative 8. So I always like looking for excuses to use the properties that I struggled with when I was learning math many years ago. So as you do math problems, when you want to and you have some extra time, find another way of simplifying them or solving them just to exercise your brain.